So again, now we're going to see what the answer is for this simple question. Hopefully you chose the moving average as your finite model, because when we look at the forecast accuracy at the ex ante, we talked about this before, we have 60% forecast accuracy for the moving average and 37% forecast accuracy for the seasonal linear. Moreover, you have a very bad bias in the moving average, a very good bias in the moving average, and a very bad bias in the seasonal linear. I'm going to go 2 and 4 to compare what you had in the ex-post, which was the previous slide and this slide. Again, we have 60 and 37 for the seasonal linear in terms of forecast accuracy, but 45% for the moving average and 76% for the seasonal linear. What does typically happen? What is the general case? Usually the moving should stay the same with the same value, should be 45%. The fact that it's 60% is because probably volatility went down, and this is a good thing. So actually the series became more simpler to forecast. What does happen every time is the seasonal model, because it comes from the family of the regression models. You always have a better ex-post accuracy than an ex-ante accuracy, because the basics of the models is to adjust to history. So it will do anything to adjust to history, including, in this case, overfitting. And this is what it's happening right now. You are having very bad results with seasonal linear because you overfit it. You interpret it naturally because of what I said, or what you know, or you've seen, that basically you have an intra-monthly pattern within the series. You think of that as being seasonality, but actually seasonality, as you know it, is different as seasonality in statistics. Seasonality in statistics is a repeated pattern, and because a month does not have a repeated pattern in terms of weeks, because some months have 4 weeks, other months have 5 weeks, the models are completely unable to understand those patterns, right? So the only thing that models understand in seasonality at a weekly level is that week 45 of this year may look the same or not as week 45 of the previous years of the previous year, and the previous year to that one, and so on and so on. And because days move when you move from one year to the other one, weeks shift, and this is where seasonality stops working, statistically speaking, when you move when you try to interpret intra-monthly patterns with weekly forecasting and seasonal models. Okay, again, we saw this before. Beware of noise, and understand when you have noise and when you have a variation that cannot be explained versus a variation that can be explained, understanding the models. And this is the key thing here. You need to understand the models to understand what the models are capable of doing. With this, we close the time series chapter. Following this, we have the behavior and classification chapter. We're going to look at demand.